All right, let's talk about something really fascinating in AI security. You have one single vulnerability, but depending on who you ask, it could be five totally different problems. How does that even work? Well, it's all about the lens you're using to look at it. Let's dive in and break this down. So really, how is that even possible? How can one little flaw, just a single thread, morph into five completely different problems? It sounds kind of crazy, right? But it all comes down to the perspective you take. And here's the thing, getting a handle on these different views, well, that's the secret sauce to building a defense that actually works. So here's our game plan. We're going to take a quick tour through five key security frameworks. We'll look at this one threat through the eyes of OWASP, then MITRE Atlas, NIST, and finally CSA and ISO. By the end, we'll see how they all fit together to give us the full picture. Ready? Let's go.
Okay, first up, OWASP. You've probably heard of them, the Open Web Application Security Project. Now think of these guys as the ultimate bug hunters. Their whole focus is zooming way in on that one specific technical flaw deep inside the code.
So from OWASP's point of view, our problem has a very specific name, prompt injection. This is where an attacker gets crafty with their input to trick the AI. It's like they're whispering in the model's ear, telling it to ignore its real job and follow their shady instructions instead. And you guessed it, that can lead to some really bad stuff, like spitting out sensitive data it should have kept secret. So for OWASP, it's pretty straightforward. At the end of the day, this whole thing is just a type of bug. That's it. It's a specific kind of flaw that you can categorize, find, and patch. Nice and simple, right? All right, let's switch lenses now and look at this from another angle with MITRE Atlas. So where OWASP zoomed in, Atlas zooms out. It takes a step back from just looking at the bug and asks a much bigger question. Okay, so there's a bug, but how would a real attacker actually use it? And this is where it gets really interesting. Atlas basically lays out the attacker's entire playbook. See, for them, that prompt injection we just talked about, that's not the whole story. It's just step one, initial access. It's how they get their foot in the door. What follows is execution. That's the model actually doing the bad thing, and maybe even exfiltration, which is the part where it ships sensitive data right out to the attacker. And that right there is the key difference. MIT Atlas doesn't just see a bug. No, it sees a whole attack chain. It's a sequence of moves, a series of tactical steps an adversary uses to get what they want. It's a story, not just a single mistake. Okay, on to lens number 3, NIST, the National Institute of Standards and Technology. Now, NIST comes at this from a completely different direction. They're not focused on the bug itself or even how the attacker uses it. Their big question is, so what? Why should the business actually care about this? So NIST gives us a pretty official-sounding name, a trust boundary failure, which, is really just a formal way of saying the guardrails broke, the defenses failed, and sensitive stuff got out. See how the focus totally shifts here? We're moving away from the nitty-gritty tech details and looking squarely at the consequences. And this is the genius of the NIST approach. It takes that technical problem and translates it into the one language everyone in an organization understands: business risk. We're talking about real dollars and cents, potential financial hits, damage to your reputation, or even getting slapped with some hefty fines. All right, we're on to our last two perspectives now, coming from the CSA, that's the Cloud Security Alliance, and ISO. Now, these two frameworks zoom out even further. They're not just looking at the bug or the attack, they're looking for much bigger systemic problems. So let's break this down. CSA looks at the system, the nuts and bolts of the technology, and asks, where did the machine break? For our prompt injection issue, they'd point to something like weak filtering in the RAG pipeline, that's retrieval augmented generation. Basically, a flaw in the system's design. But then you have ISO. They look at the process, the human side of things, and ask, why did we let this happen? And their answer would be something like, well, we were missing the right security controls, our policies weren't strict enough, and nobody was really watching. It's a process gap.
Okay, so let's recap. We've seen this one threat as a bug, an attack chain, a business risk, a system flaw, and a process gap. We've looked through all 5 lenses. Now, let's assemble the full picture.
And here it is. This is what it all looks like when you put it together. One single threat, 5 totally essential perspectives. You've got OWASP seeing the specific bug, the prompt injection. You've got MITRE Atlas mapping out the attack chain. Then there's NIST calculating the business risk. CSA points to the system flaw in the RAG pipeline. And finally, ISO highlights the process gap in your governance. And the crazy part?
Every single one of these views is correct. They're all just different, critical pieces of the same puzzle.
And this is the big takeaway, right? You absolutely cannot build a complete solid defense if you're only looking at part of the problem. If you just stick to one framework, you're guaranteed to have massive blind spots. To really lock down our AI systems, we have to be able to see the threat from every single one of these angles. So, that leaves us with one final question, and this one's for you. Take a good look at this whole picture. Which one of these lenses, the bug, the attack, the risk, the system, or the process, which one is your team maybe not looking through right now? Because figuring that out, that could be the most important first step you take toward building a much, much stronger defense.